So let's have this problem. So for this angle length projectile motion, and these are the things we need to remember. So this is the given angle, the angle theta. Then we have the initial velocity, and this is the initial velocity for x. Then the initial velocity for y. Then from this point to this point, this is the range or the horizontal displacement. So we have the dx or the range, and this is now the peak height or the maximum height. So the peak height or the maximum height, then we have the vertical displacement, and take note from the peak height, the final velocity for y is equal to 0. Then to find the total time of flight, so from this point to the peak height, this is time up, and from the maximum height to this point, this is the time down. Then take note the time up is equal to the time down. So therefore, to find the total flight time, this is equal to 2 times the time up. Then observe from this initial velocity, the initial velocity for x and the initial velocity for y. So we have this, the right triangle. So this is theta, the initial velocity for x, and the initial velocity for y. So from this right triangle, using the trigonometric function, we can find the initial velocity for x equal, so using this formula, the initial velocity times cosine theta, and to find the initial velocity for y, so we have the initial velocity times sine theta. So these are the two formulas to find the initial velocity for x and the initial velocity for y. Then we have these different formulas. So let's have first the formulas for y, and that's the final velocity for y equals the initial velocity for y plus the gravity times the time. And take note that the gravity, this one is constant, that's negative 9.8 meters per second squared. Then we also have the other formula for y. So the final velocity for y squared equals the initial velocity for y squared plus 2 times the gravity times the vertical displacement or the dy. Then to solve for dy, so we have the initial velocity for y times the time plus 1/2 times the gravity times time to the power 2. Then we only have one formula for x, and that's the dx equals the initial velocity for x times the time, because for x or in the horizontal, the acceleration is equal to 0 meters per second squared. So these are the things we need to remember for this angle length projectile motion. Then to solve for this problem, so a projectile is launched at 42.7 meters per second. So this one is the initial velocity, and an angle of 37.4 degrees. This one is theta. Then find the time of flight, so the total time, then the range or the horizontal distance, this is the dx, then the peak height, this one is the dy. So this is now the illustration. So we have the given angle, that's 37.4 degrees, and the initial velocity, that's 42.7 meters per second. So first, we need to find the initial velocity for x using this formula. So the initial velocity times cosine theta. Then we have now the initial velocity is 42.7. Then times cosine theta. Theta is 37.4 degrees. Then to find now the initial velocity for x. So we have 42.7 then times cosine 37.4 equals, so that's 33.92. So this is 33.92 meters per second. So this is now the initial velocity for x. Then for the initial velocity for y, so this formula, the initial velocity times cosine theta, then substitute now the values. So we have 42.7, then sine 37.4 degrees. Then to find the initial velocity for y, so we have 42.7, then times sine 37.4 equals, so that's 25.93. So this is 25.93 meters per second. So we have now the initial velocity for y. Then before solving for the time of flight, so we need to list first all the given. So for y, these are the given. So we have the final velocity for y equals 0 from the peak height. So this final velocity is 0. And also the initial velocity for y, that's 25.93 meters per second. And also the gravity for y, this is constant, negative 9.8 meters per second squared. So these are the givens for y. And for x, so we only have one given for x. The initial velocity for x, that's 33.92 meters per second. Then this time, to find out this time of flight, so we have A, solve for the time of flight using this formula. So we have the final velocity for y equals the initial velocity for y, then plus the gravity times the time. So take note that from this formula, we are only solving the time up. So we're using the final velocity equals 0. So the final velocity is 0 equals the initial velocity for y, that's 25.93 meters per second, then plus the gravity, that's negative 9.8 meters per second squared times the time, then transpose. So this becomes negative 25.93 meters per second, then equals negative 9.8 meters per second squared times the time, then divide both sides by negative 9.8 meters per second squared divided by negative 9.8 meters per second squared. So cancel. So again, this one is just only for time up. So we have the time up equals this negative 25.93 divided by 9.8. So negative 25.93 divided by negative 9.8. So equals positive 2.65. So this is positive 2.65 seconds. Then to find the total flight time, so for the total time, this is equal to 2 times the time up. So the time up is 2.65 seconds. So we have now the total flight time. So that's 2 then times 2.65 equals, so the total flight time is 5.3 seconds. So this is 5.3 seconds. So this is now the total flight time. Then this time to solve for the range. So to solve for the range or the horizontal displacement, so using this formula, so we have dx equals Vix, or the initial velocity for x, times the total flight time. Then substitute now the values to solve for the range or the dx. So the initial velocity for x, that's 33.92 meters per second times the time or the total flight time. Because this is the range, so we need this total flight time. So that's 5.3 seconds. Then dx or the range equals, so 33.92 then times 5.3 equals, that's 179.78. So this is 179.78 meters. So the range or the horizontal distance is 179.78 meters. Then to solve for the peak height or the maximum height, so to solve for the peak height or the maximum height, so using this formula, the final velocity for y then squared equals the initial velocity for y then squared plus 2 times the gravity times the dy. So for this final velocity for y, for the peak height, that's equal to 0. So this is 0 squared equals the initial velocity for y, that's 25.93 meters per second, then squared, then plus 2 times the gravity, negative 9.8 meters per second squared, times the dy. Then we have now 0 for 0 squared equals this 25.93 to the power 2. So we have 25.93 to the power 2, that's equal to 672.36 So this is 672.36, then meter squared, second squared, and this 2 times negative 9.8. So we have 2 times negative 9.8. So that's negative 19.6. So this is negative 19.6. Then meters per second squared times the dy. Then this time to solve for the peak height, so transpose this 672.36 to the other side. So this becomes negative 672.36, then meters squared second squared equals negative 19.6 meters per second squared times the dy. And to solve for dy, so we need to divide both sides by this negative 19.6. So to solve for dy, so we have this negative 672.36 meters per second squared equals negative 19.6 meters per second squared times the dy. So divide both sides by negative 19.6 meters per second squared. Divide by negative 19.6 meters per second squared, then cancel. So therefore the dy or the peak height or the maximum height, so negative 672.36 divided by negative 19.6 equals that's 34.30. So the peak height is 34.30 meters.